All right, so that's getting started. Give it a second. All right. Let's minimize that. And now let me share my screen. All right, can everybody see my screen? I imagine yes. Okay, great, awesome. All right, excellent. All right, yes. So there. Yeah, there's a question. If you have a question about the quiz, you can contact me offline. We can discuss that a bit later. So yeah, you can feel free to reach out to me. You can text me or call me. I'll put it here on the chat. Okay, and you can grab that. And yes, I will release the answers right after this lecture. We've made available, and you can take a look at the answers and post a feedback if if you're contesting some of your answers that might have not matched or not. Okay. All right, excellent. So let's see. Right, so we are starting our 5th week. We in the first week we installed a relational database, MySQL. We created a couple of tables, inserted, and showed you some simple interactions there. We then spent about a week on designing the database using class diagrams and seeing how is that we can structure the data by implementing certain concepts such as one-to-many, many-to-many, things like that. Also made sure that it was normalized, right, that there was no redundancy to avoid inconsistency. So we spent a good chunk of time there. And the 3rd week, we actually looked at how we could actually implement the database that we had designed using the create statement in terms of using the relational model of creating tables that had rows, that had records that could reference each other using primary key, foreign key. Last week we spent about a week talking about, if the database had data, if somebody had populated this data with the database, how is that we could retrieve it using the select statement, how we could retrieve from a single table, from multiple tables, doing joins, doing grouping, things like that. Right. So today, in this week, we're going to be practicing on how is that we can update the data, right, or insert or create data and put it there in the first place, right? So we'll be spending about a week discussing that. All right, so that's then I also made a couple of changes to the schedule. In the syllabus here, I moved the exam to be on week number 7 as opposed to week number 6. Right, I think it was a little bit too close. So yeah, so now it's going to be the end of not next week, but the week after that, right? So yeah, so that's going to be like March 5th. That's going to be the first exam. So that exam is going to be very much like the quizzes that you've had so far. They're going to be online. They're going to be asynchronous. They're going to be the exam is going to be available for 48 hours, starting early in the morning that Friday, throughout Saturday, and obviously you'll have much more time. You'll have about, I think, maybe like 2 hours, maybe more, where you can you answer questions about multiple topics. We're going to be covering all the topics that we covered up to this week, which is updating the database. Next week, we're going to start covering some more advanced topics. We'll talk about programming the database next week. So that's not going to be in the exam, the topic from next week. That'll be in the following quiz, following exam later on. Okay. So yeah, so starting next week, we're going to be discussing some advanced ways of interacting with the database as opposed to the console. We'll do some programming using creating store procedures, triggers, functions, things like that, that will allow us to use some high-level programming languages to interact with the database. When we come back from the first exam, we'll continue talking about how is that we can integrate with databases using object relational models, and how can these be mapped to one another, objects and classes. There's many features that are not, they don't have a one-to-one mapping. So we'll see how to achieve this integration. We'll also see how we can integrate a simple user interface based on some simple web technologies, so that you can start thinking about creating a project and based on some simple user interface interactions. We'll talk about transactions, NoSQL as we come back. So that's the plan for the next couple of weeks. Let's see. So any questions on the new schedule?
I have a question about the exam. I know it's kind of like far-fetched to ask a question like this, but would we get like a sample test or anything to kind of see like the structure of the question?
Yes. Yep. Yeah, exactly. So we will provide sample questions, and we'll spend also that the day before the exam, not the day, well, the lecture before the exam, which is about 2-3 days before. We'll also have a study guide, and we'll have some sample questions for everybody. Yeah, that will be made available, certainly.
Thank you.
Yep. All right, excellent. So let's get going. So let's talk about the assignment for this week. So this week, if you click on DB5, and it's about updating the database. It's all about updating. It's going to give us a chance to practice how is it that we're going to update an existing database, right? So by updating, we mean 3 operations, right? Being able to add data to the database, modify data that's already there, or remove data from that is already in the database, right? So along with the querying and the select operations that we used last week, together this week, by the end of this week, we're going to be able to do all the basic operations with relational databases, right? We're going to be able to create data, read data, retrieve data. We need to be able to update data and delete data, right? And those 4 operations, oftentimes we refer to them as the CRUD operations, right? Create, read, update, and delete, right? So by the end of this week, we'll have completed, all the major basic operations that we would expect to be doing when we interact with relational databases, right? And the week after that, we'll start just considering more advanced ways of interacting using programming, using stored procedures, functions, and triggers, right? Still within the database, right? But they're much more advanced features. Okay. All right. So let's talk about the assignments that's going to go out today, and will be due a week from now. We're still using the same database that we've been playing around for the last month or so, right? Where it's a really simple blogging application, right? We have users that can log in, register, and then they can either create any number of blogs. Some folks might create blogs about sports, others about food, and others about finance. Here we've been playing around with some blogs about space and cars, and then the owners of those blogs can then post to the different blogs. So a user might have many blogs, and then each blog might have many posts. We also have a couple of many-to-many mappings here, where any other user, right, could reply to a post, right? Whether they agree with the post, they don't agree with the post, right? So they can go into a hierarchical conversation about the post and reply and have a discussion amongst themselves. They also can rate the post and say, thumbs up, thumbs down, or give it a 5-star, 3-star rating, maybe leave a one-time comment, right, on that particular post. So we'll stick to this theme, throughout the semester. So in this assignment, we're going to be practicing again how to import databases, more or less what we've been doing. We're going to give you again a database that you're going to import, and this is going to blow away any data you might have had from the previous assignment. So this is going to guarantee that that everybody has the same, everybody starts from the same place, right? Everybody's gonna have the same data. And then what we ask you to do is based on the data that's already there, okay? So, right, if you have some data in the original database from the previous assignment, you're gonna lose that. So you might want to export it or something. Also, some of the fields might have changed names. So some queries that might have worked before previously might not work again now, okay? We're also going to practice these 3 operations, being able to insert records into relational database, update existing records, or delete records, okay? All right, so so again, like we've done before, and like we're going to be doing on all assignments, we're first going to demo the part where we show you how to do something, right? And then ask you on your own, right, to try to replicate somehow what we just did, right? So we do it for you, and then we ask you to do it on your own, okay? So yeah, and all assignments going to follow that same pattern. So okay, so first of all, we're going to download the database, and you can download it from my repository here. You can download. I've downloaded already a couple of times, and I'm going to open it, and it's going to expand it into a directory. There it is, DB design number 5. The number doesn't matter. What the content, what matters is the content. And you'll notice that here you'll have several SQL statements, right, that you can open up. And so let's open up with Workbench. And if you open it up, you'll notice that basically it's blowing away your old database, your old tables, and just recreating the tables, and then populating that data. For instance, it's inserting Alice, Bob, Tim, Elon, blah blah blah. Just putting in a whole bunch of users, right? It's basically doing it for everybody. Okay. All right. Excellent. So let's import it following the instructions here, and the instructions are basically the same from last assignment. It says to go into the server, data import, and then import the project folder. All right, so let's do that. We can go to server, let's say data import, and we're going to navigate to that directory. And that would be, I believe it's downloads, and this is the design, the directory we just created. We're going to say open, and we're going to say start import. All right, so this blows away any information I had before, and I can refresh and make sure that everything's okay. I believe I created these 2 tables from the prior lecture, so I'm going to blow that away since I want to do that again here for you. The drop table, drop there. There we go. And so you'll notice that the data that is in there, it includes user information. So you can click on users here, and there you have Tim Dodd, Elon, Charlie, Daniel, Craig, Alice, and Bob. Okay, A, B, C, D. Yeah, so we got data in there. Pretty much the same data that you had from the previous assignment. All right, so okay, so the first part that you're gonna learn about and you're gonna practice is about inserting new data into a database, right? And so there are a couple of different syntax on how is that you insert new data into the database. One of the simpler ones is this syntax, right, where you say I'm gonna insert data into a particular table, and then you list the columns and the values for each one of those columns, right? So that's one of the easier syntax. And you need to make sure that the order of the columns here matches the order of the values, and the data type of these values matches the data types of the columns that were listed here, right? So here, first we're going to ask you, right, to first insert a couple of new users, right? So this is the demo. This is what we demo for you, and then we're going to ask you to do something similar, all right? So first we're going to ask you first get a hold of all the users just to see what's there, and we ask you to do it in a screen in a new window, right? And you're going to save this window. You're going to do all your work in this one window, and at the end you're going to save this into a file, and that's what you're going to submit, right? And in each statement that you paste here, make sure that you have some comment, a comment that explains your query, right? Making sure that you understand what you're writing, and others who read this also make sure that they understand what's going on. So if you run this, right, it comes back with a result set. These are the current users, right? So and we want to see what the users were before we do the insert. So let's insert. Let's see, we have 6 users. Let's insert a new user. We'll insert Edward Scissorhands. And if we do a select again, you'll notice that indeed number 7 was added there. See that? And we can insert yet another one. I'm going to insert Frank. Okay, so this is Frank Herbert. He's the author of the book Dune, for which there's a major motion picture that was supposed to come out late last year, but because of COVID, was postponed to later this year. I'm very excited for that movie. So yeah, so Frank Herbert. So we inserted Frank Herbert, and then we can do a select to see and confirm, make sure that indeed that user was inserted. Run that, and select that. There we go. There we have Edward, the new 2 users that we added, Edward and Frank. Perfect. So yeah, so we were able to insert those 2 folks. Excellent. So now we ask you to do something similar. Let's see, is there a question on the chat? Will default value be inserted in the number of input and columns doesn't match? Yeah, we'll talk about that in a minute when we cover insert in formally. But yes, definitely if you skip over a field that you're not listing, right? Definitely, right? If you have a default value and you're not listing it, then it'll take the default value. If you don't provide the value but you don't have a default, right, then it'll take null if it can accept null, right? If it says not null, you definitely have to provide the value or configure the default value. But we'll cover that in a minute in the lecture. Yes, thanks. Right, so we're asking you, right, to create a couple of blogs, right? So you'll be doing this on your own, right? You'll be creating, from these 2 new users, Edward and Frank. We ask you to, in the same screen, create 2 new blogs. One called the Angry Astronaut, and one called for NASA Spaceflight, both by Edward Scissorhands, right? So if you remember all the blogs, if you take a look at all the blogs, if you look at all the blogs here, right, they have the last column here is who the owner of the blog is, right? So 34466, right? So since we've created these 2 new users, Edward, not that one. Which one? Close that. There, we created Edward and Frank. We're asking you that these 2 new blogs, Edward Scissorhands should be the owner, so number 8. So use ID number 8. Now, your ID might be different, okay? So if it's 9 or 10 or 11, whatever ID Edward Scissorhands turns out to be, make sure you use that ID, right? Also, if anywhere in the assignment the IDs don't match with what you have, right, feel free to change the ID, right, and to fix it so that the query does work, right? So it might be, that your database might be configured slightly different, and so the ID numbers might not match exactly, right? My database is configured to do auto increment 1 at a time, 1, 2, 3, but some folks might have configured the database to start at 10 and then 20, 30, 40, right? So I don't know how you have your database configured, right? So these assignments are based on auto increments starting at 1, but you might have configured your database slightly different because of some other course, some other, for whatever reason, right? So if the IDs don't match, feel free to tweak those IDs for the queries to work for you. Okay, so anyway, so create 2 blogs, the Angry Astronaut and NASA Spaceflight, and Edward Scissorhands is the owner for both. Right? Use the new ID for Edward Scissorhands. All right, so do that on your own. All right, so there's another syntax for inserting. The other syntax is you get to omit the columns, right? So you don't list the columns, right? Whereas the previous syntax, you listed the columns. Okay, so in this case, right, you don't list the columns. And so the question is, well, how does it figure out which values match for what columns, right? And the way it does that is by looking at the original definition of the table, right? And what it'll do is that it'll use these values to match the order of the columns as they were declared, okay? So that it'll match value 1 with column A, value 2 with column B, and so on and so forth, right? In that order. So whereas here, right, the order, right, was established by the listing, the explicit listing of the columns. Here, the order is declared by the way it was created. The table was created originally. Make sense? So obviously that changes a little bit whether you can skip something, how you skip it, right? And so it's slightly different the way you use it. So here we ask you to create a couple of blogs, right? So for instance, taking a look at the original blogs, right? If you run that, these are the blogs, and you might have inserted a couple more, right? From the previous question, you might have inserted a couple more blogs, and so here we're going to insert a couple more blogs here. We're going to insert one that talks about cars, okay? And so insert here a blog called E for electric, and so that's a electric car blog. So we copy that and we paste it here. It's basically a blog that talks about cars or electric cars, right? So if we run that and we select again, we see that we have inserted a new record in there. Perfect. And then we're going to insert another one called Space Eccentric. So you can guess what that is, right? It's a blog about space, and actually SpaceX in specifically SpaceX. And so those are two new blogs, and we can just list what the blogs are after the blogs have been added, so that we can confirm that the blogs have been created. Okay. Also, notice I'm using ID number 6 as the owner of this blog. Again, if for some reason that ID doesn't work for you, right? Because you have your auto increment configured differently, please feel free to change that ID to something that works for you. Okay. Also notice that we're using current date, the function current date, for a default value of the created and updated, right, to be initialized for the current date, right? I believe they already have a default value, so we could have skipped over these, right? Since they were going to have a default value anyway. All right, so now you try it, right? And you try it. So what we're asking you to do is find some information about Tesla and some information about SpaceX. Go out to Google something about Tesla and SpaceX, right? And then create 2 posts, right, for the 2 blogs that we created. So for this one, right, there's a brand new blog we just created. So find 2 topics or 2 posts on Tesla, and then insert those 2 posts and use this E for electric as being the blog for those 2 posts. Okay, then create 2 records, right, about SpaceX, and make this blog the parent blog. Okay, makes sense? Right, so in total, you're going to have 4 records. You're going to be inserting 4 records, right? 2 for this blog and 2 for this other blog. Right, 2 about Tesla for this blog and 2 about SpaceX for this other blog. Make sense? Pretty good. All right, let's keep going. So another syntax in the insert in the insert statement, right, allows you to copy data from some source table into some target table, right? So for instance, here, we're going to insert into table 2. Okay, there's a question on the chat. Let's see. How do we make a blog a parent of another blog? No. The posts are going to have the parent blog, right? So blogs are not hierarchical. So blog does not own a blog. Posts have a parent blog, right? Based on this ID, right? So the posts have a foreign key to the parent blog. Okay. All right. Copying. Where are we? Yeah. So this allows you to take data that already exists in one table, right, and copy it into another target table, right? So it says, these records that live in some other table, or it might be multiple tables too, right? It might be data that you bring from multiple tables, right? And then you massage it, and then you insert it into a target table. And that's exactly what we're going to do, right? We're going to create, right? We're going to create a new table called unliked posts, right? And these unliked posts, it's going to have the we're going to keep track, right, of which posts had thumbs down, right, that people didn't like. Okay, we want to record the ID of the post, who didn't like this post, what was the original blog where this post appeared. So these are all IDs, and these are all foreign keys pointing to the original records, right? But we're going to bring over also the username of the person who posted this or didn't like it. We're going to bring in the original post, right? What was the actual content that people didn't like, and the name of the blog. Okay, so not only are we going to grab the IDs, but the actual information about that. Okay, and those are the foreign keys. All right, so let's do that. So we grab that, we copy it over here. Right, we paste that. So we're going to drop the table if it exists, but it doesn't exist because it doesn't exist, right? So we're going to, and then run that, and it's going to create a new table called unliked posts, right? So if we looked at the unliked post, okay, I'm going to refresh, and now see that we have unliked posts. Right now it's empty. There's nothing in there. There is so no records. So we're going to populate it, and what we're going to put in there, we're going to grab some data from the user table, so that we can fill in the user information, the username and the user. We're going to grab some data from the posts table, so we can populate the post ID and the post. And we're going to grab some information from the blog table, and so we can populate the blog name and the blog ID. We also need to filter, right? And says we only want the unliked posts, right? So that information is in the ratings table, right? Ratings table, where we have liked and unliked. So we're going to join all these 4 tables. We're going to join them together, right? Find all the foreign keys and primary keys, blah, 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 right? Sourcing all this information, and then we're going to populate this table over here, right? So let's do that. So the way we're going to do that, right, is that we're going to use this insert and select. It's called the insert select syntax. So in your insert into select syntax, okay? And so we're going to populate this table, the unliked post that you just created. What are we going to put in there? Well, whatever comes back after the select. Okay, so let's do that. If you grab the select, you grab that select, right, and you paste it in here, paste it in there. Let's see what this is, right? If you run that, it comes back with 2 values, right? And let's look at this select. So the select is basically what? Select says, okay, well, I want to insert into this table, and that table, it expects what? It expects this data. It expects the ID of the post, the ID of the user, the ID of the blog, username, post, and blog name. And those are the fields that are expected post ID, user ID, blog ID, username, blah, 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 right? Those are the, so this select, when it generates the data, right? Notice that it generates it perfectly. It generates it with the field names and in the order in which that table expects, right? I mean, these are records that could very well live in this unliked posts, right? Post ID, user ID, blog ID, username, post, and blog name, right? So this query would perfectly fit into that table, okay? But notice that we had to use these as. See that as, right? Because notice what would happen if we didn't have these as, right? Let's look at the original data without these as. So as allows us to rename the fields, right? Let's run that. Let's run that again. Let's run that again. Notice that it would come back with ID, 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 username, post, and blog name, okay? Which is not quite what the unlike post expects, right? These three are fine, username, post, and blog name, right? Matches here, right? Matches this, username, post, and blog name. But these ID, 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 that's not what I'm expecting. Poster ID, user ID, and blog ID. That's why, right, we are renaming, right, the results here using the as keyword, right? So that the resulting of this query matches the insert, the target schema. Make sense? Also, we're putting it in the right order. We're putting it in the order in which you expect. All right, and also what is it doing, right? We are joining in the from clause. We're saying, okay, we're going to join all these four tables, okay, and we are using the implicit join syntax, right, where we have a whole bunch of predicates, right, that match the ratings user ID with the user ID, right? So we can go grab the user who did the rating, right? We can say, okay, well, this rating was generated by that user over there. Right, we can also grab the post because I have a reference to the post, right? So we say, okay, that's the post that this person didn't like, right? And we can also grab from the post, I can match the blog, right? So I can say, okay, well, this post belongs to that blog. So now, once I have matched all three records, or all four records from all four tables, right? I can also filter and says, well, I only want the ones where the likes are 0, right? That people have selected to do a thumbs down, right? So these first three predicates allow me to do the join, and this last predicate allows me to filter and say I only want the unlike ones, right? Once I have the data, this is the data. I then put the insert in front of it. I put the insert right in front of it, saying that select that comes in, I want to copy it into the unlike, which right now it's empty. There's nothing in there. There's nothing in there. But putting the insert says, these two records you're generating, this result set, well, put it into the unlike table, right? So if we do that and run this, okay, now if we go to the unlike table and we refresh, notice that we have permanently put the data in there, right? It's no longer a temporary result in the result grid. Now it's being permanently inserted into that table, right, for permanent storage. So that maybe this is like an annual report or like a weekly report, right, that can be used for some additional processing on that data. Okay. All right. So yeah. So we demoed that. We are asking you now to do that on your own. What we did for the liked posts, I'm sorry, what we did for the unliked posts, we're asking you to do it for the liked posts, right? And looking at it now, it's a little bit too easy. This is kind of trivial. All right, too bad. Too late now. So yeah, so with what we've given you, you should be able to take what we've done and play around with it, and then generate and populate the liked posts. Okay. All right. We then ask you to practice and play around with the updating existing records. So all we've done right now is create, right? Create new data. The C in CRUD, right? Read, we spent all last week doing the R, reading data from the database, right? We just covered the C, the create. So CRU, the update. So let's talk about updating data. So the syntax is you want to update a table. You want to update records in a table that match a particular criteria, right? That says, okay, well, I want to update the records that exist in this table. I want to modify these columns or these fields with some new values, right? Where certain conditions apply, right? So if you have 1,000 records, you might not want to update all 1,000 records. Probably you want to update a few records, maybe just one, right? Or maybe a dozen. And so where allows you to say, okay, well, I want to update these dozen records, right? And then what do we want to do with it? Well, these fields, I want to change these values. Okay. So what we're going to do here is that we're going to go fetch all the ratings, right? All the liked ratings, and then we're gonna do some modifications, right? So all these are the ratings for a post whose ID is 1. There they are. And notice that this post has some likes, some dislikes, has a couple scores, right, from different folks like these or not, right? So we're going to update to make sure that everybody likes it, right? Maybe somebody inadvertently clicked on the unlike button, like thumbs down, but maybe they changed their mind, right? And they want to change it back to up. It says, oh, no, I really do like this post. Change it to positive. So how do we do that? We're going to update and set the likes to a 1, right? Where the ratings is equal to 5, right? So we're going to do that. And let's copy that in here. And if we run that, okay, and then do a select again, you'll notice that now they're all 1s, right? So everybody now likes that particular post. Okay. All right. So now we ask you to do something on your own. We're going to say, okay, well, now we showed you how to modify the ratings, the liked. So what you're going to do is that you're also going to modify ratings, but instead of modifying the likes, you're going to modify the scores, right? So we're going to say, update the score for one of the records in the ratings table. Set the score to 3 for the records whose ID is 9. Okay. Okay. Now, again, some of these IDs, right? If 9 doesn't work for you, or if 5 doesn't work for you, feel free to to use another ID, right, to complete this step, right? Finally, we ask you to practice delete, right, and delete a rating from a user number 2, right? So if we look at our ratings by user number 2 here, right, and user 2 has this rating, so we're asking you to just remove that from ratings. And let's see, we can do that. Where user ID, okay, and if we look at the ratings for that post, right, user number 2 is gone. Okay, there we go. And then what we ask you to do on your own is remove all ratings whose score is less than 3, less than or equal to 3, right? Meaning any ratings below 3, like for instance, is 3 less than or equal to 3. So this one would go away. Or if you have another rating less than 3, would also be removed. Okay, so that's what we ask you to do. Make sure that when you do all your queries, make sure that everything has a comment. Right? Everything has a little comment that explains what is happening, what's going on, right? They have, right, and that you have, and that everything is being saved in one file. So by the end of the this exercise, you should have a whole bunch of selects and inserts and updates and deletes, right? And you should have all these, right? The one that inserted Edward, the one that inserted Frank, that then found all the users, that inserted the angry astronaut, NASA space flight, right? E for electric, blah, 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 blah. All the creating of the tables, the updatings, the removals. So everything should be in this one file, okay, with its own comments, and then save that into a file called updating databases.sql, and then submit that file in Canvas or Blackboard. Okay. All right, that's the assignment for this week. Any questions? All right. Let's see. There's a question in the chat. It says, is there an easy way in MySQL to find the key pairs between two tables? The key pairs. I don't know what you mean by that. Key pairs. You mean the name of the IDs or the values? I mean, if you know what the keys are, you can just print out the values of those key pairs. All right, if we can maybe discuss it a little later if you want to chat maybe tonight in the.
I have a
Yes.
question, Professor.
Yes.
So can you switch around the order for select insert? Wouldn't it sound better to say select this and then insert it instead of doing insert first, right? Insert first, then select.
Yeah, well, it's a syntax, right? It's the standard syntax. There's a couple more instructions that that are not standard.
Order matters then in this case.
Yes. Yeah.
Okay.
You have the insert and then followed by the select. Yep.
Thank you.
Yep. Oh, yeah. Awesome. Good question. All right. So let's talk about. So we covered most everything we need, right? We're now just going to go over it, making sure that we didn't miss anything, that we covered all the different syntax. All right, and filling in any gaps. So we're going to formally cover this. Let's see. All right, let's see. Put this away. All right, so let's talk about insert. All right, so insert, again, as the name suggests, right, it allows you to create new records into a table, and this is one of the most common syntax that you use it. You say insert into table, and you just list the value without listing the columns, right? And so a simple example is that if you have a table called maybe persons, and you insert a new person, Craig Daniel, right? You end up with a new record at the end, right? The order in the records in the table doesn't actually matter, right? We put at the bottom because logically we think of things being appended at the end, but in reality these are all should be considered as sets, and the order doesn't actually matter. Also, even though this is being incremented one at a time, right? And you would say, well, I should be able to just sort by that ID. Well, you're not guaranteed that these are monotonously incrementing values, right? That they could be random, right? And we'll see later on when we talk about non-relational databases, right? That these are just unique identifiers, right? That are not necessarily incrementing. So you should always consider this as just being a sets, right? As opposed to arrays. So anyway, so the order here, when you don't list the fields, when you don't list the columns, the order is taken by based on the original order of the fields when the table was created, right? So the first one matches the first field, the second one, the second, and so on and so forth, right? So you have to make sure that the order and the data type matches, right? So if the first one's supposed to be an integer, then you have to make sure that it indeed is an integer, and so on and so forth, okay? Now you can skip over values, or you can omit values, and if you omit them, then the default value for that field comes into play. Okay, so for instance here we are skipping over the last field, D, column D, and if D allows null, then it will get null. Right? If it doesn't allow null, right, you'll get an error. It'll say, oh, nope, you can't do that. You can't insert a record with a field that is a required field. Okay. If you have a default value and you don't provide the value, then it'll take the default value, right? But if there is no default value and you allow null, then it will take null. Okay, so if you do provide the default value, right? If you don't provide a value, then it will take that default value, or null. Okay, so for instance, the way you specify the default value is that you have default and then the value that is, so that if you skip it, right, it'll take that one value 123.45. Okay, now if you so careful if you want to skip a value, say you want to provide the value for D but not C, okay, you can't just say 123 comma or maybe even you might be tempted to say just leave it blank, right, and put a comma in there, and feel that it's going to skip over, and that's a syntax error, right? Instead, right, it'll try to match this with the first one, and then the second one here with this one over here, right? So the order, right, again, is strictly determined by the original declaration of the table, right? If you want to skip over because you don't have a value for that particular value, you can skip it by providing null, meaning I don't have a value for you, right? And that's only if the field accepts a null, right? And that's actually the default. The default fields will by default be declared as null, right? So it would be fine for you to provide a null or just skip over the value, and you would not be you would not get an error, right? But if you try to do that with a not null, you'll definitely get an error, right? Okay, so the alternative syntax is to actually provide the columns and say, which columns you want to insert, right? Where now the order and the data types is not dictated by the original create statement, right, with the order in which you declare all those fields, but now the order is dictated by the listing of the columns over here, okay? So here we have column 1, 2, and 3, and these values are matched with the same order in which you declare these columns in here, right? Now, because you're specifying the columns, now you can move these around, right? It'll be perfectly fine to do, column 3 over here, right, and column 1 down here. It doesn't matter because now it's by the name of the column, not by the order in which the create statement declares them. The order you're specifying it here, right here in the insert statements, right? So you can move them around, right, any which way, and you can skip over them, right, because you're listing exactly which columns you're working with, okay? So here's an example. We are inserting a new person, Edward Norton, here with a specific ID number 5. Notice that we're skipping over address and city, and that would be okay if those fields allow a null, right? But if they're configured not null, right, the database would stop me and not let me insert this record, right? But presumably here these fields by default they accept null. Okay, here's another example. We are inserting into the students table, right? And the columns that we're not providing presumably are taking default values, right? Or they're being left null if they allow a null, right? So this is just to point out again that the order, right, is of the values needs to match the column order that you're listed here. Okay. So here let's review a couple of things about the default values and let's look at several scenarios. Here, imagine you have column A, table A, and you have B, C, D, and E, where they're all integers, but there's only one of them has a default configuration of 234, right? So say you provide the value of B and E, right, as B being 1, 2, 3, and E being null. Okay. So if that's the case here, you have that B is going to take the value 1, 2, 3. C is going to take the value of the default value 2, 3, 4. Whereas D, right, because we did not provide a value for it, and it's not configured not null, right? Then because we didn't provide the value, right, it's going to take the value of null. Okay. And E, we are explicitly saying that we want the null value. So there it is. So B, C, D, and E, right? And these are the values that end up being inserted. Okay. All right. So let's revisit this now. What if we configure D, right, to not accept null, right? Whereas over here, right, D was not configured. So this is implicit having this here, right? It is implicit that these fields allow and accept null, right? Actually, when you do a create statement here and you don't provide either null or not null, the actual statement that gets generated is the null. It's configured with null, all right? So yeah, so when you explicitly say not null and you insert like this, right, and you're not providing a value of D, right, this would get an error saying, oops, nope, D is a required field. You have to give me a value or configure a default value, right? You have to do one or the other. So to fix this, you either can do one of the two things. We can either configure a default value, default 321, right? Because you've configured to be not null, right? You can do that, and or right, the other way, the alternative is to just provide the value for D, right, of 543. Provided because it was default. I'm sorry, that it's a required value. It doesn't have a default, right? So you either provide you configure default, and or right, you insert and you provide the value instead of an insert. Okay. All right, so then there's insert into select, which is basically, we saw earlier, allows you to copy data, right, from source, from some source tables, right? You can go fetch data from multiple tables, right, and then come back, collate all that information, and then all those records that you've identified in using the where clause and the select statement, then you can insert into a target table. So here's an example, right, where we're targeting a table that has these three columns, column 1, 2, 3, and then the source tables could be just one table, could be two tables, could be three, any number of tables, right? So here we're sourcing from two tables, T1 and T2, right? Now the columns in T1 and T2, they might be all over the place, right? The names of the columns. Now you have to make sure, right, that the columns that you're inserting into, you have to make sure that the data that is being generated by your select statement, has the structure, the same structure that the target table has, right? So that the names of the column match, the order of the column matches, right? The data types match. That's all your responsibility, right? Like we just illustrated earlier, right? So for instance, here we have two tables. We are filtering identify which actual records we want to insert, right? And we do that in the where clause, right? Probably we're joining 2, 3, 4 tables. We're joining that. We're filtering based on some predicate. So once we have identified what records we want to insert, right, or copy from the source tables, we need to make sure that the names match, right? That the names match by using the as keyword, right? Right. So here, for instance, we're illustrating that table T1 has a field called C1, but the target table is expecting column 1, COL1. So we are renaming C1 into col1. Same thing here, right? Notice that T2 has a column called C3, but the target table is expecting column 3, right? So we are making sure we rename it into the expected name, okay? Obviously, we'll have to make sure that, that if you're expecting 3 columns, then we have 3 columns over here. And that if you're expecting an integer, a varchar, and a date, well, we'll make sure that this is an integer and a varchar and a date, right? So we have to make sure that all those things match. Make sense? Okay, so here's an example, right? Imagine we create a table called alumni, right? That has 4 fields: an ID, name of the students, their major, where they graduated, right, and the year that they graduated. Okay, so alumni presumably is a subset of the students that have already graduated, right? So the way we can do that, we can have a select statement. Here's a select statement that can identify who has graduated already. Okay, and we can do that by taking a look at 2 tables, maybe like a students table and the department table, right? And then identifying the students for the major that they graduated in, and then taking a look at the year, that their graduation year, and see if the graduation year is in the future or it's in the past, right? So we can compare the graduation year of the student and see if it's less than, meaning if it's in the past of today's date. If it's in the past, then we're going to take him and say, okay, well, he must be an alumni, right? Right. If it's in the future, then they haven't yet graduated, right? So this select statement, right, joins 2 tables, 2 source tables, right? The student table and the department table, and then filters and finding only the ones whose graduation year is in the past, right? So having identified students who graduated in the past, we're going to copy them into an alumni table, right? And in here, notice that all the names match. Actually, no. This is SID, and this needs to be ID. So yeah, this is missing as ID. Okay. I guess we have to do the same name, same thing here. Yeah, this is supposed to be as name, and D name as major. Okay, and this one we don't have to do anything because graduation year is graduation year. Let's make this smaller so it fits. There we go. Yeah, so notice that we rename everything, right? So to make sure that things match. Okay, let's split this into two lines like that, so it's easier to read. There we go. There we go. Okay. Yeah, so notice that D name is part of the department, so we'll rename it major because that's what you're expecting here, right? To insert into the major table over here, right? So we use as. Make sense? All right, excellent. So yeah, so this is just reiterating, right, that the names, right, need to match, right, in the target table that you're inserting into, and that you need to use the as. So here's a generic example, right, where you have multiple source tables, right, that might have fields E and F and G and H, right? But you're expecting them to be A, B, C, D because that is the target table that you're inserting to, right? So just remember that you need to rename them, right, to match the names, obviously the order, obviously, and also the data types. Okay. Obviously, you can instead of sourcing from multiple tables, you can also just source from one table, maybe even from the same table. Maybe you want to copy a record in the same table and paste it inside of the same table. Like for instance, here we are sourcing from the students table and we're inserting again into the students table, right? And basically what we're doing here is that we're copying, right, one record maybe from one student and using that, right, an existing student as a source to paste it into the same table, right? Maybe these students are brothers and sisters maybe, and they're in the same department. They're going to graduate the same year and whatnot. Maybe it's a large family or something, and so you want to maybe copy from the same students and then just copy over most of the data, right? And then just reinsert in the database. And the only thing that you're changing, you might be changing just a single thing. Maybe you're changing maybe just the name of the student, right? And maybe you're copying from Scott and the same department, same graduation year, blah blah blah. And you want to copy maybe that into Dan, Barry and Gary and blah blah blah, right? And the same record multiple times, and you're only just modifying, you're tweaking some of the data, right? So you're copying a single record. And finally, this syntax of creating the table, inserting and selecting, actually there's a dedicated syntax for this, right? Instead of creating the table first and then doing an insert select, you can actually combine this into a single syntax, right? And you can just remove the insert. If you just remove the insert, you get this, right? This is a create table. You create the table, and you don't even have to provide the schema. You don't even have to provide the names of the fields or the data types or anything like that. You just say create a table, and that table will be created from whatever you select, right? So any fields that you create here, any fields, the names of the fields, right? The data types of those fields from wherever you're sourcing this, from whatever tables you're going to fetch, 3, 4, 5, 6 different tables, right? You're creating this, right? And then you're creating a table, a brand new table right on the fly. You're creating a table that is going to contain the data that you might have sourced from multiple tables. So this is This is almost like a view, right? This is almost like a view, right? The difference is that in a view is temporary, right? Meaning it creates the data, right, on the fly that you select, right? And then every time you query that view, it reruns the query, right? It's not permanent. The data that the view returns with, and you can use it as if it were a table, right? But every time you reference that view, the data is generated brand new. The select statement gets run brand new. Okay, so it could get very expensive if this is a view that is heavily trafficked, right? And that it's referenced multiple times, right? It could get very, very expensive, right? So there is an opportunity to improve performance by identifying a view that it has lots and lots of reads, and you might not have any writes, right? Or very few writes. You're not updating any of the tables underneath, right? So the view is almost the same data all the time. So why regenerate it every single time? Okay. So an opportunity to improve that is to use this syntax and make the view permanent, right? So that the query only executes once and never again, right? And this table gets generated, and now I can query against it, and I don't have to do the query again, right? This idea is this idea of optimizing views, and depending on how many inserts, how many updates, how many queries you're doing, right, of this optimization. This technique is sometimes referred to as materialized views. Materialized views are views that have been made permanent, okay, with the intent of improving performance, and where you know that this is a view that's heavily used, lots and lots of reads. You're not doing any inserts, so you don't have to regenerate the view. The nice things about the view is that any changes in the underlying tables would be reflected in the view, whereas over here, not, right? Any changes in the source tables would not be reflected in this target table, right? You would have to regenerate the table brand new, right? To show that there were any changes on the underlying source. So that's a you have to weigh in your pros and cons, right, on whether it's a good idea or not, right? So anyway, any questions so far in our inserts? Pretty straightforward, right? Okay, so let's move on. Let's talk about update now. Right, so like the name suggests, updates and deletes, right? This allows us to update and delete records that already exist, right? That already been inserted, right? I want to come back later and decide, oh well, I don't want those records anymore, right? Or I want to update records that are there. I want to change a few things, right? So let's first look at delete, right? So delete. The syntax of the delete statement is delete from table, right? Or you can put also the asterisk in there. You can say delete star from table. Now, usually you don't use the delete statement just like that, right? Because like that, it basically would be interpreted as deleting all the records, right, in that table. And usually that's not what we want, okay? Usually the delete statement goes along with the where clause, has a where clause where you identify which records are you deleting, right? And using the predicate saying, okay, well, these are actually the records. Now, I don't want to remove all 1,000 records. Instead, these are the 2 or 3 records that I want to remove with a where clause where this is true, right? Now, most databases, if you try to do a delete without a where clause, right, will stop you and says, no, you can't do that, right? It'll warn you. It'll say, are you sure, right, that you want to remove all 10,000 records in this database, in this table, right? And it'll stop you. And usually the database is put in some mode that will check and verify that that you don't inadvertently just blow away a table. Okay, so here's the syntax of using the delete, right, from the persons, right? Delete from persons where this is true and that is true, right? So we're identifying that this is the record that we want to remove, and then boom, it's gone, right? So the record is no longer there, and it's permanent, it's gone, right? There's no way of going back. Well, unless you have it in a transaction, but we don't know what a transaction is. We'll talk about transactions a little later. So here's another delete example, a little more sophisticated delete example. Here we are using the select statement, the delete statement, and notice the where clause here. The where clause is narrowing in a specific subset of the records that we want to remove. And the way we're doing it, right, is that we're first identifying here in a select statement, we're identifying those sections for which there is an enrollment. Okay, so basically we're going to the enrollment table, right? And we're saying, okay, well, give me all the section IDs in the enrollment table, right? So that comes back with all the section IDs that are in the enrollment table. So basically, I might have more sections opens than they are enrolled, right? There might be, I was over optimistic, and for this course, I opened up 10 sections, right? But it turned out that only 6 of those 10 sections folks actually enrolled in, right? So this would tell me, oh, there are only 6 sections, right, that have entry in the enrollments table. That means that there might be 4 sections that nobody enrolled for, right? So I want to identify who those are. So this where clause here does that for me. That where clause says, okay, well, I've identified the section IDs for which there are enrollments. Well, I want the section IDs for which there are no enrollments that are not in that list, right? So this might come back with the 6 sections that have enrollment, and these are the ones that are not in that list. That gives me the 4 sections, right, that are not in the enrollments table, right? So I want to delete those sections. So delete the sections for which there are no enrollments, right? Boom, they're gone, which makes sense, right? I want to close. I don't want to leave open sections for which nobody has enrolled in. So this is a way of doing that. Okay. All right. So let's take a look now at the update. So the update, has a syntax of listing and providing the name of the table that you want to update, right? And then a list of field value, comma separated list of name value pair, right? I want to identify certain records in a particular table for which I want to change, right, a certain number of fields, and here are the values, right? So the where clause allows me to identify which are the records that I want to modify, right? And then the column allows me to say, well, for this column, I want to set this value. For this column, I want to set this value, blah, 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 right? I want to go all the way through and update those, right? Now, careful, because the update can be used without the where clause, right? So, and just like in the delete, right, the interpretation that if you do not have a where clause, the interpretation is that you want to update all the records in that table. And probably that's not what you want, right? So make sure that you do have a where clause. You do have a where clause of saying, out of the 1,000 records, these are the 2 or 3 records that I want to update, and these are the fields that I want to modify, and these are the new values. Okay, so here's an example of Edward Norton, right? That didn't have an address, right? They were homeless, and so we're going to update and give them a house at 45 Groton Road in Lowell. Right, we're going to set an address in the city for which the Norton last name and first name is Edward Norton. Okay, and then careful that you don't omit the where, right? If you don't have the where clause, right, then you have everybody living in the same area, in the same address, right? So basically that's no, right? So I mean, maybe that's what you want. Maybe you want to give all the employees, you want to give them a 5% increase in salary. Then sure, yeah, right. This would work, right? You would take all the employees and just update their salary by 5%. Maybe that is what you want to do. Very generous. So here's another example on updating a record and making the value of one of the fields based on a previous value, which is pretty cool, right? You can say, change the current graduation value make it so that it's one more than the previous one, right? So that's pretty cool. You can refer to previous values of those records. That's nice. And notice what we're doing here. We're also changing the foreign key, right? So presumably the student ID, presumably they used to be in one major. Maybe they were in, in anthropology or something, right? And the department closed, right? Nobody's learning anything about anthropology. Everybody went, everybody's switched over to computer science, and we're changing their major, right, from 20 to 10, and now everybody, just that was in that small little department, everybody moved over to computer science, and because of because of the growing pains, right, they might need an extra year to catch up, right, and be productive. All right, so does shorthand plus equal? No, that doesn't work, right? That's in programming languages. Yes, not here. Nope. Okay. All right. So that's that for update. So any questions about that? All right. Yeah. So let's move on. All right. So I did want to revisit group by. Right. We did cover group by in our previous lecture, but I do want to cover it again a little bit further, since there's some nuances on how group by works, right? And because of the way it works, right, there are some limitations on certain things that you can do and you can't do with group by, right? So let's revisit group by and see what we talked about in the previous lecture. So yeah, so remember, what group by does is that it takes a whole bunch of records, and it looks at one of the fields. Let me maybe bring that here. Let me just copy this. Maybe here it might help. Okay. So for instance, if you have a whole bunch of records and you're grouping by a particular field, you can say that I want to group by whatever field. You can choose whatever field you want. Okay. And so for instance, maybe you can group by section ID. Okay. So what it does is that as it goes through all these 12 records, right, it looks at the values of the field you're grouping by, and if the values are the same, then it says, they all go in a particular bucket, right? So these 12 records would end up in 3 different buckets, right? The bucket where section ID is 1, the bucket where section ID is 2, and another bucket, a third bucket where section ID is 3. Make sense? We could have grouped by something else. We could have grouped by the grade, right? Then we would have what? The bucket where you have the A's, you have the bucket where you have the B's, right? You have a bucket where you have the C's, and you have the buckets where you have the D's, right? You would end up with 4 buckets, right? One bucket for A, another bucket for B, a bucket for C, another bucket for D. Or you group by section ID. You can also group by a combination of section ID and grade. So that means that wherever these are the same with any one other, then you have another bucket, right? So there's the bucket of section ID with grade A. So there's a bucket here with 1A, and then another bucket with 1B, and then a third bucket with 2A, and then another bucket with 2B, then another bucket 3A, and then a bucket with 3B, 3C, and 3D, right? So you end up with 1, 2, 3, 4, 5, 6, 7, 8 buckets, right? So there's many different ways that you can do and calculate these buckets, right? Let's not call them buckets, we'll call them groups. All right. So let's just take one of these. Let's just take one of these. Right. So say you're grouping by section. Right. Say you're grouping by section. Okay. So you end up with 3 groups, the groups of 1, 2s, and 3s. All right. So basically the result set on the other end, after you select group by section ID, is that you have three groups, right? Now, in the select, when you say select, what can you put in the select? What can you put in the select? Okay, in the projection. In the projection, there's a limitation of what you can put, what is valid to put in that section, in that select. Well, one of the things that you can put in the select is the field by which you grouped by. Right? If you say you selected section ID group by section ID, you would end up with three answers, right? Three rows, 1, 2, and 3, 1, 2, and 3, because those are the values of section ID. The question is, what happens to the other fields? What happens to the other fields? Right? What happens to student ID? What happens to EID? What happens to grade? What do you do with those? Right? Can you put in the select statement the field grade? Well, you couldn't. You couldn't put the field grade, right? Because if this is true that in these three buckets, the value of section ID has distinct values, right? In the bucket number 1, section ID is always 1. For the bucket number 2, the section ID is always 2, right? And for the bucket number 3, the value of section ID is always 3. But what about grade? Well, in bucket 1, you have 2 values for grade. In bucket 2, you also have 2 values of the grade. Whereas in bucket number 3, you have 4 different values for grade. So if you say select section ID, comma, grade, well, for section ID, you have the values 1, 2, and 3. So 3 different rows, 3 different values. But for the grade, what are you going to put? In the bucket 1, you have 2 values. In bucket 2, you have 2 values. In bucket 3, you have 4 values. What are you going to put in there? Right? So it would be a syntax error, right, to put grade in the select statement. Okay, so let's look at the closer why that's the case. Right? So let's look at this. So formally, right, this is the syntax. Right? You say select columns. What columns can you put here? What columns can you put here? Well, only the columns by which you group by. Only the columns by which you group by. See that? You cannot put other columns, right? If you don't group by them, then you cannot put them in there. It's syntactically incorrect. Why? Well, because for a given group, those other columns can have multiple values, right? You cannot put them in there, right? What you can put for the other columns, you have to aggregate them, right? Because if you have multiple values of grades, A, B, C, D, well, what can you do? Well, you have to aggregate it. Well, can you aggregate A, B, C, D? Well, maybe not, right? If you had if A is 95 and B is 85, right? What you could do is maybe average them out, right? You can average, right, 85 and 95, right, and get what the final grade is. Yes. So you can put aggregates of the other columns, but you can't put the actual columns in the select statement. Yes, you got to be careful, right? It would be a syntactical error, right, to put the other columns in there. And why? Well, again, because these other columns have multiple values per bucket, right, per group. Right? So that you only can do the aggregates of them. Right? So let's take a look at an example, right? Say you have this table, right? We have customer, you have Alice 3 times, you have Charlie 2 times, right? And you have Bob 1 time, right? So you can group by, say you group by customer. So that means that this would end up being 3 buckets, right? The Alice bucket, the Charlie bucket, and the Bob bucket. But for Alice, the value for order price has 1, 2, 3 values, right? 1, 2, 3 values, right? So in the resulting select statement, you could say select customer because you are grouping by customer. But you could not say select customer, comma, order price, because for customer, you have a single value, but for orders, you have 1, 2, 3 values, right? So you could not say, you could say select customer, right? Because you group by customer, but you could not say comma order price because you would have 3 values. What would you put in there? You could put sum of the order price, which is the addition, right? Is the addition all 3 values. That's okay. So you can put the aggregation, right, of those 3 values, but you cannot, you don't have those values anymore. They're gone, right? They have been aggregated into a single value. Right? So these values are gone. You don't have them. Okay, they have been aggregated. All right. So careful, right? Because it could be this could be in a quiz question, right? Or it could be an assignment, right? It would be syntactically incorrect to put those not on those fields that are not in the group by. Okay. All right. So let's take a look at again another syntax that we played around with. What happens if you use an aggregate function in the select clause, but you don't group by, right? So if you don't use explicit group by over here, but you do have an aggregate, right? The database is going to do an implicit group. Right? It's going to take the whole table as if it were one single group. Okay, so it can calculate the aggregation based on that one big group, right? So what it's going to do is that, for instance, if you have a sum of the order, it's just going to take the whole thing as one big bucket, right? And just going to go and add all the values in that one big bucket, right? And add the whole thing that comes out to be, 5,700, right? And right, and since you're retrieving the customer, then you're going to go to all the customers, but the values are going to be all the same for all the records in there. Okay, so yeah, so understand that. Now you can also, as I mentioned earlier, you can group by multiple. You can group by multiple fields, right? And like we did here, right? We mentioned here you can group by not only section ID, but you can group by the combination of section ID and grade. So wherever they are the same, then that becomes one bucket. So that's one bucket. That's a second bucket. That's a third bucket, right? Okay, wherever both fields are the same for multiple records, then they all fit in the same bucket, right? So here we're for instance, we are grouping where the customer and the order date are the same. They fit in the same bucket. Now, because I am grouping by these 2 fields, then it's totally fine to list those 2 fields in their select statement. See that? Right? I can use them because I am grouping by those 2 fields. Okay? Any other field, it would need to be aggregated. All right? So here's another example. We are grouping by major ID. Right? So we're I don't know, do we have major ID here? We don't have major ID. So we're grouping from the students table, we're grouping on the foreign key major ID that is referencing the major, right? And then within that major, we want to calculate, based on all the students in a particular major, right? We want to look at all the graduation year, right? And we are aggregating, right, all the years into a minimum and a maximum, right? Calculating the min and max. So these are 2 of several aggregation functions, right? Those okay, is the question right now? Yeah, min, max, average, sum, count. Those are all the aggregation functions that are available to you. Okay. All right. Okay. So we did talk about some limitations, right? Of what can you provide? What is it that you can put in the select statement? Now, why is it, right? And so we're going to talk about what are some of the limitations of, because of how group works, certain things that you can do and you cannot do, and how to get around them, right? So let's look at how group by works behind the scenes, right? So the reason you cannot put fields that are not group by, right, in the select statement is that it's because the group by gets calculated after we do the where clause, right? So you do, select, right, from blah, 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 where. So where, remember, the where does a filter, right? It says, out of 10,000 records, right, I'm going to filter and come up with just 100 records. So where first identifies which out of the thousands of records, I only want to look at these half dozen records, right? So after the where clause runs and identifies the records, then the group by runs, right? So the group by is calculated after the where, okay, which makes sense, right? You have 1,000 records and you identify, oh, I just want these couple dozen records. Now I'm going to group by and decide which buckets I'm going to look at, right? But once the bucket gets calculated, the bucketing, right, of which group goes, which records go with group, that happens before the select statement runs, right? So first we identify the buckets. Once the buckets are identified, then we calculate the select statement. So by the time you get to the select statement, right, by the time you get to the select statements, the only thing that you have in the buckets are the fields by which you grouped by and any aggregates of the other fields, okay? So by the time you get to the select statement, you don't have the original values, right, of the records that got into those buckets, right? Only the aggregates, right? You don't have access to the original values. They're gone, right? You can only aggregate them, okay? So those fields are inaccessible to you, right? So this has large implications of what you can and what you cannot do. Let's take a look at an example that we played around, earlier this semester, right? We were calculating the number of A's and we wanted to know, which, the sections and the number of A's and who had the maximum A's and the minimum A's, right? Let's revisit that. Let's revisit that now that we know some of the limitations of the group by, what can you and what you cannot do. Let's see. So we had done the following, right? We had said, take a look at the sections, right? Look at the enrollments, and in the enrollments, find me all the sections, right, and that had A's, right? So let's look at the enrollments. Let's look at the grades. Let's go find all the students that got an A, right? Then group by the section because I want to count how many A's there are per section. Okay, and you end up with something like this, right? If you have these A's, right, in section 1, you end up with 2 A's. In section 2, you find out you have 3 A's. In section 3, you have 1 A. Okay, so that's what this comes up with. This comes up says that section 1 has 2, section 2 has 3, and section 3 has 1. Then you take that result, and you feed it into another group, right, where you're grouping the whole table, the whole Q83. Okay, so you end up with something like this, right? So section 1 gets 2.
Professor,
Yes.
you just cut out.
Oh yeah, I think it just told me here. Yeah, let me
Thank you
repeat
so
that.
much.
Yeah, thank you. Yes, let me repeat that. Yeah, so this query, right, after you group by and saying that section 1 gets 2 and section 2 gets 3 and section 3 gets 1, right? You get something like this, right, where the first query that you're identifying the grades of A, group by the section ID, and you're counting how many A's there are, you end up with this result, right, where section 1 gets 2, section 2 is 3, and section 3 is 1, right? And then if we take that Q83 and we feed it, right, into another group by over here, where we group the entire table, meaning we're grouping this whole thing, this whole thing, we're grouping it, right? And we are aggregating the number of A's, right, by identifying the max, right? It would give you this 3 over here. And that's why this comes out as 3. But notice that what we've done is that we have grouped the entire table as one big group, right, to identify and what the 3 is here. And because it's one big bucket, right, if we have they have this one big bucket, by the time you get to the select statement, this section, this information, right, in the big bucket, this section here is gone. We don't have that information because in this 1, 3 here, there are 3 section IDs, right? Just like before, right? We were looking at this when we were grouping by customer, right? If you added order price, you have 3 values, right? Same thing here. Same thing here. If this is one big group and you're aggregating and you get the number of A's is 3, if you add here section ID, you get 3 values, 1, 2, and 3, right? So you don't really have a correspondence anymore of 3 to 2. You have 3 to 1, 2, 3. Okay, so this is problematic if we want to be able to answer the following question. Right now, there's no question. There's no problem. We were able to do everything, right? But say somebody asks us, right, and wants to go a little further and say, oh, well, don't only tell me the maximum number of A's, also tell me what section are they in? Where does this happen? Who had the maximum number of A's? Right? It'd be nice to know not only the maximum number of A's, but also know this section ID, right? Okay. But this is syntactical error, right? The database would stop you and say, no, you can't do that, right? Because here in the we don't have a group by, but remember when we leave out the group by, you're taking the whole table as one big group, right? So section ID is not part of the group by, so you cannot put section ID in your select statement, right? Because again, here, what you get back is one big bucket, and the values are really 1, 2, 3, right? You don't have any more the correspondence of having the actual value 2, right? So this is illegal, and the database would stop you and says, well, I don't know. Right? I don't know that 3 was any and was related to 2. You lost that information. Okay. So an alternative one might think, it says, well, what if we could, instead of doing the aggregation on the select statement, like we did over here, right? We're doing the aggregation, the max number of A's. What if we could do it on the where clause? So we could say, okay, well, calculate the maximum number of A's, and then I can use that as a join, right? As a predicate, right, to filter and tell me what section ID it is, right? But this is also illegal. This is also illegal, right? You cannot have aggregation functions in the where clause. Aggregation functions only can happen in the select clause. Or, as we'll see in a minute, they can happen in the having clause, okay? So this cannot be done because you can only aggregate after you have identified the buckets, right? After you have identified the groups, and the groups are only happen after the where clause, meaning the where clause hasn't happened yet. If the where clause hasn't happened yet, I haven't identified the groups. If I don't have the groups, how can I do the aggregation, right? So this is kind of like a chicken and egg. I cannot do the max until after I do the where clause, right? So this is illegal. This is illegal, right? So anyways, this is a hack around this, right? There's a hack around this where we can join these 2 values, right? These two queries, Q83 and Q84, we can join them together, right? We can join them together, Q83 and Q84, where we can make these values 3 equal to this value 3 here, right? And then we can extract the 2, right? Which is somewhat of a hack, right? Because what if you had multiple number of A's equal to 3? It would match multiple sections, but nevertheless, certainly it would yield the right answer, right? You can join these 2 tables, right, where the number of A's is equal to the max number of A's, and then you can extract the section ID from this table over here. There's a question on the did I cut out again?
No, I think that was from the past time when you.
Oh, okay. Thank you. So yeah, so definitely is a workaround, right? There's a workaround which is somewhat hacky, but definitely it would work. So ideally, instead, what you can do is to use what another command called the having, right? Having, you're just like there's a group by clause, there's a from clause, there's a where clause, there is a having clause, right? That allows you to do exactly what we want. Have aggregate functions in the where clause, right? So this happens after the group by, meaning where happens, the group happens, and then you can have an aggregate, but before the select statement, right? So the group happens, and then you can provide the aggregate functions where it aggregates, and then you can use it as part of a filter or as part of a predicate, right, that allows you to filter which records meet that aggregate. So for instance, that's an example where you have here, you have multiple orders, right, where you can maybe group by the customer. So you have, Boone would be one group, Nielsen would be another group, right, and Jensen all by themselves, right? And you say, okay, well, now I want to filter, right, and I can do an aggregate of the orders price, right, and then I can filter, say, well, give me the ones that are less than 2,000, right, and then it comes back with Nielsen, which has the aggregate of 1,600, which is 100 plus the customer, which we normally would have not gotten, right? Because and so here, for instance, we can do greater than 1,500, right? And so the having clause allows us to have both aggregates, right, and also as part of the where clause that we could not earlier. Okay. All right, folks. That's all. That's all I had for you today. So yeah, the assignment went out. It's due next Tuesday. Also later this week, we're going to have the third quiz, which will be made available later on Friday, which will be part of the material will be on the previous week, right? Which we did select, and reading and retrieving data from the database. Okay. All right. Anybody have a question?
I have a question for the quizzes.
Yes.
Is it possible maybe you can kind of like give an example, like answer and question at the beginning, because I was really confused on the format. I don't know if anyone else was, but I just found it somewhat confusing.
Okay. Yes, I guess I should cover that. Yeah, let's take a look at real quick on the quiz, say number 2, is it?
Yeah.
Okay, so quiz 2. And let's edit.
Yeah, this was just the first time we saw like the fill in the blank, and it was just kind of
okay, sure.
Like
sure.
I understood what you were asking, I just didn't know what to put.
Okay. Yeah, so here's an example question number 1. It says, given the following UML class diagram, we wanted to be able to create this, right? So presumably we're filling the blanks to create this this table A, right? So these were presumably the data types, right? So this would be int here, right? String, presumably this would be varchar, right? Date, I think this is, I think we were supposed to use parentheses. We were supposed to use, no parentheses. Yeah, no, it says, yes, at the beginning here, it says not to use any of these special characters like commas, colon, or parentheses, or any quotation marks or anything like that, right? Yeah, so this was, and I think tiny int for Boolean, so there was no need to put the parentheses for tiny int. If you put parentheses, that's also would be fine. We would accept that as well. Obviously, there's going to be more work for us to verify that that you didn't do that. But if you had tiny int anywhere in your D, that would be acceptable. If you we're going to go over the answers and make sure that nobody got docked with the points off of for adding any parentheses. But if you did, make sure that you point it out to us, and we'll give you we'll give you the points back. Okay.
I have a question, Professor.
Yes.
So for the first problem, date, are we supposed to use date time or date?
Date time.
Oh, I used date time. I got it wrong.
Okay, then yeah, we'll correct that and give you the points back.
All right, but is date a different data type than date time? Are they different or?
So, some databases will support date. Some databases only support date to time. So, but we'll accept date as well.
Okay, thank you.
Yeah.
I have
we
a
were hoping
question
that you would use the same data types that we use in class, and so the quiz is based on what we've seen in class and the lectures. But if you're using Oracle or SQL Server data types, we'll accept them as well.
There were some questions in the chat about the Boolean type. I remember that SQL uses tiny int, but Boolean also works too. Like
Yes,
on
it
the
does.
homework, Boolean works. So would that have been an acceptable answer?
Yeah, that's acceptable, yes. And if you lost points, we'll give them back to you.
Will we see what we got wrong and right, like by
yes,
Thursday?
because I'll make the answers available and you can compare. And also I'll make a post so that you can post any issues, and we'll fix it for everybody. So we'll fix it for one, and then I'll re-grade everybody. Yep. So for this one, I think this was a foreign key primary key, right? It says many R's are related to an instance of T, right? So this is a primary key, so this will be a foreign key. So foreign key, right? Foreign key R references R ID. Okay.
Yeah, these are the ones I had trouble on. I don't know. For some reason, like obviously, like I knew it was a foreign key, but I didn't know you wanted me to write foreign, then key, and then like references, or like just in that weird format. I guess I don't know if that makes any sense.
Yeah, no, we had put several versions. We have, for instance, added some possibilities that if you had put foreign key, all of it in one single field, but we would accept that as well. And so we'll see how people answered, and whatever makes more sense that to allow various ways that people might have answered, we'll accept those as well, and these will be regraded. And but if your answer makes sense, you'll certainly get the credit for it. Yeah,
I looked at like this one because the rest of the problems were like this, probably for a good like 15 of the minutes we had to answer it. And I was kind of just like, oh, like, does he want us to include kind of how you set up the tables on top, like integer, not null. So I didn't know if you wanted that in each individual slot as well, which was what confused me a lot. And then I realized you kind of just wanted to be
again, if you did put ain't, not null, yada yada yada, we'll give it to you. We're hoping that you only use one word per field, and so you would have to put in the minimum possible configuration for this to work, right? So for instance, int is definitely required, not null is not required, right?
Mm-hmm.
Right.
Yeah.
So perhaps that was missing from the instructions, and so I'll add it, right? I'll say the absolute minimum that you would need for this to work. So yeah, no, definitely. I'm sorry.
Oh, I have a question on that one specifically.
Oh, which one? Previous one?
Yeah, previous one. I can talk about it. It's about, because it says this would be a many-to-one relationship because there are many instances of R related to one instance of T. Would it? I think I got it right in the end, but I thought like it would make more sense to create table T, because why would in table T we need to reference table R? Because I thought you do a foreign key in table R instead of table T.
Backwards. Oh no, it's right. One instance of many instances of R. It's backwards.
Yeah, I was really confused on this one.
Yeah, no, you're right. This is totally backwards. Yeah, this should have been T and this should have been R. Okay, I'll give everybody the point for everybody. Yeah, it's
nice.
Yeah, it's written backwards. Sorry about that. Yep. Yeah, definitely give points everybody to that. Good catch. Good catch. Yep.
I spent like 5 minutes on that question.
Yeah,
Like 10 minutes on that question out of 30.
Yeah. So this question was for many to many. So many instances of W are related to many instances of Q. So here's was a mapping table E, which presumably was pointing to Q and W, right? So these two would be two foreign keys that are relating Q and W. One is pointing to one and one is pointing to the other. So this would be foreign key Q references QID, and foreign key W references WID. Okay. And this was a kind of like a self-reference, right? Where you had a table that had a primary key, and then you had a self-reference that pointed back to itself, right? And so this would be like foreign key. So this would be where the primary key and foreign key both would the primary key was also a foreign key that referenced itself, right? So the foreign key X references X ID, right? So anyway, I'm going to look at all the answers for everybody, and we're going to go over it. And if your answer is just vaguely makes sense, then we'll give you the full credit.
I have a question on that one. I think for the last block, I wrote XID, something like that.
Where?
Instead of X parentheses ID, because I think I was mimicking like one of the slides or something where it had a different format, but it did have ID in it.
Right. Yeah, XID would work as well, but we were hoping that you would write ID, just ID in there. But yes, X.ID would work as well.
So even though you have like the caution of like, oh, only use one word, you're pretty lenient with the grading still.
Yes.
Okay.
Hopefully, 90% of folks will follow the instructions, so we'll have to deal with the edge cases, and we try to minimize those edge cases. And so to minimize the manual grading, but definitely we'll go over each one and make sure that everybody gets the full, as much credit as you deserve.
Yeah, I think it would even be helpful if you just had like even one of these past questions and just had like a correct answer, just so we know the format exactly of what you wanted. That way it makes it easier on you, but also us.
Okay. All right. Sure.
Thank you, Professor. Have a great
All
day.
right. Thank you. Bye-bye. Take care.
Thank you.
Bye.
Thank you so much. I appreciate everything.
All right. Take care. You too.